Hello everyone, I'm Satish from the Department of CSE IB and I am here to present our IBS2 uh, biological systems, intelligent biological systems. Uh, Project title is a greedy algorithm for minimizing the number of primers in multiple PCR experiments. In this project, we have combined biology and computer science to solve the practical problem. So let me take you through what we have done. Here is an abstract. You can quickly go through the abstract and I'm off. Hope we have done. Now, let me briefly explain what here it is. In molecular biology, PCR or polymerase chain reaction is a method used to amplify DNA sequences. When we want to amplify multiple targets across various DNA sequences, we often need many unique primers, which increase cost and complexity. So, our project introduces a greedy algorithm to select a minimal number of primers by choosing the ones that cover the most targets. This reduces redundancy and improves efficiency in experiments. We have implemented this idea using Python and even built a simple GUI to make tool more interactive. Now, here is an overview of what I'll be covering in this presentation. Let me show what the contents here are. Introduction, project objectives. Uh, just go through all this. Hope you are done. Just pause the screen for reading all those. I will be just giving you a second. Let me explain from where. I'll begin with a short introduction to the problem and explain our project's objectives. Then I will give you some background context and show you how we modeled this as a computer science problem. After that, I will walk through the method we used, followed by current progress and results. Finally, I'll summarize everything and share a few references too. Let's start with the introduction. Again, one more time, give you a time. Hope you have done. Sorry. Yeah, hope you are done. Now I'll give you a brief introduction. PCR is used in labs to amplify specific regions of DNA using short DNA sequences called primes. Now, multiplex PCR goes one step further by amplifying multiple targets at the same time. But here is the problem. Using a unique primer for each target becomes inefficient as the number of targets increases. So, our project aims to optimize primer selection using a greedy algorithm, making the whole process faster and cheaper. To make this user friendly, we also develop a GUI using Python. Next, let me quickly outline what we set out to achieve through this project. Here are project objectives. Quickly go through it. What we have done. Now, let me explain. We had four keys. We had four key objectives in mind. First, to minimize the number of panels used in multiplex PCR experiments. Now, second, to maximize primary use by choosing ones that match multiple targets. Third, to implement this strategy using a greedy algorithm for efficiency. And finally, to build a graphical interface so that users can easily test and visualize results. Now, Let me give us some background on how this connects with algorithmic concepts. Let me go through the background. Here is our first one, use cases in this theory, algorithm. Uh, you can actually read without turning off my cam, I guess. Hope you're done. This problem actually connects really well to the set cover problem in algorithms. We treat each primer as a set and each DNA target as an element. The goal is to cover all elements using few sets, meaning primers, as possible. This kind of solution has multiple use cases, including I mean, genetic diagnostics, pathogenic detection, biodiversity studies, even agriculture, identifying GMOs, everything. Okay, now let's go to other one. Now let's compare our approach with other existing methods. Here are comparison with other methods. Even this tool can read, I guess. Yeah, let me explain. Compared to brute force or dynamic programming, greedy algorithms are much faster and easier to scale. They might not give the absolute best solution every time, but they were practical for real datasets. Of course, there are some limitations. Here are, let me tell you, our current version only supports exact matches. It doesn't validate biological quality like GC content or melting temperature. And as mentioned, greedy solutions are not always optimal. That said, um, we already have few improvements in mind. Here, what are the improvements, limitations, and challenges? Hope you can read this too also. Now let me explain. Some planned upgrades includes adding mismatch tolerance to handle near matches, generating reverse primer for full PCR setup, including biological constraints like GC content and TM. And finally, allowing users to export selected primers in lab-friendly formats like CSV or FASTA. Now, let's dive into the method we used. Real-world improvements. Yeah, this too can wait. Our method starts with a set of DNA sequences and a fixed primer length, like 4 or 5 bases. We can scan each sequence to extract all possible strings and substrings of that length. These are our candidate primers. Then we check which primers match which targets. From there, we apply greedy algorithm. We, we pick the primer that covers the most uncovered targets, add it to solution and mark those targets as covered. This repeats until all targets are covered. Remember this. This repeats until all targets are covered. Okay. We can go through or repeat if you don't understand anything. Let me go through other methods, Python and GUI implementations. Here are method slides, problem formulation, timer extraction, greedy set, algorithm, graphical user interface, and output validation. Oh, sorry, I forgot to show a full slide. Hope you have done really. Hmm. Let me show you other slide. This is our code implementations. Now you can read, I guess. When we adjust from this camera. If you want, we can go through these codes we have done. I'll explain you briefly later. That's it. Mm. Let me explain you this. We implemented the logic in Python using sets and dictionaries for efficient mapping. Then we built a graphical user interface using Tkinter. The GUI allows users to enter multiple data sequences, select primers, primer length, and view the selected primers as output. It's simple, functional, and helps visualize how algorithm works in real time. Now, let me show where we are actually, the current status. Um, I have done some output, some tried out examples here. So you can see this is work completed. Work completed. Work pending is on next slide. Sorry. Okay. Oh, sorry, I didn't explain you our output. It's a snapshot of our output. The tool successfully reduces the number of primers used. It shows which primer covers which sequences, and it displays how many total primers are needed. We tested it with sample data, as I said earlier, and saw good results compared to nav methods. Nav methods. Let me tell you what we have done until now. The completed work. Hope you are done reading. Now let me explain. So far, here is what we have accomplished. Oh, sorry. Hope you can see full screen of this. Yeah, here is what we have accomplished. We clearly defined the problem and reached the existing solutions. Implemented the 3D algorithm and the GUI. We tested it with the different sequences and validated the output. We also documented our code and created this presentation. Now, let's look at what's we left with pending work. Quickly go through it. Yeah, hope you have done. Let me tell you. We still have few tasks pending. We need to test with larger and more deserved DNA datasets and adding biological checks like melting temperature and GC contents, improve support for mismatches, generate reverse primers, and allow users to export the output of the lab use. Also, we plan to refine the UI based feedback and finalize the presentation. Let me go through this primary, most summary of this. Oh, yeah, sorry. Here are roles, what we have done. Let me explain my role. My role is to responsible for creating the presentation. Yeah, this is our presentation. Then the algorithm usability too. Task I have done is design PowerPoint slides. This everything is done by me. And sorry, my friends to help me preparing it. Uh, Yes, images were added by me to enhance understanding. Perform. Oh, sorry. Let me show you this. But I forgot to show. Yeah, actually, I don't want to hack myself. So let me skip this. Let me go through some. Hope you have done. To summarize, we developed a fast, simple solution to reduce the number of primers in PCR using a greedy algorithm. We built an interactive GUI and tested it successfully with the sample data. Actually, GUI part is not with me currently now. It's with my friend Srikanth. He will show you in his video the GUI part. The up to an idea, the demo part is with me. So let me show you that at the end. Uh, what we had on is with future improvements, this could grow into a powerful bioinformation, informatic tool that helps researchers save time, cost, and effort. Yeah. Next, what slide we have? The roles again. Sorry, this is a match like this. This slide is should be that. So yeah, here is what we have done. Enhancing here. Enhancement is done here. By me. What's it, I guess. Okay. Thank you so much for watching my presentation. I'm sure. Bye bye.